Hey everyone, this is Bathymetrics. Welcome to episode 4 of my video series called Mixing Loud with Clip to Zero. In this video, I'm going to be dispelling some myths and fuzzy understanding about whether clippers are somehow bad for your speaker drivers, especially club and festival speaker drivers. Spoiler, they're not, at least not if you do it right and think about a few common sense things. I'm also going to be showing you a fourth plugin that I just learned about, and I'm now considering this to also be a must-have for my Clip to Zero method. Fortunately, this is a free plugin, so there's no reason not to grab it too, as you prep for the upcoming episodes where I'm going to start showing you how to work in the Clip to Zero way. Now, before I start with the content of this video, I should point out this is part of an ongoing series. I'll be building out this YouTube playlist on my channel, and I'm going to be covering a whole lot of juicy topics about how to do Clip to Zero in the coming weeks, and I recommend you subscribe to my channel so you can know when each new episode comes out. Also, let me make clear that I don't have any promotional relationship with any of the vendors of the plugins I use, okay? These are all just great plugins that I use myself, I paid for myself, and I use them every day to make Clip to Zero workflow easy and simple. Okay, so let's get right to this particular episode. This is actually kind of a follow-on to episode 3, where I talked about the plugins you're going to need for this method. I did not have a good plugin-based solution for one aspect of CTZ. I was planning to tell you how to cobble up this approach in your DAW using native DAW devices, but it actually turns out somebody in the comment thread for episode 3 said, hey, did you know about this cool plugin by Blue Cat? This will solve that problem. And I'm like, oh my gosh, this is great. So I went out and checked out that plugin, and I will be showing it to you in just a second. Basically, it's by Blue Cat Audio. If you go to the Blue Cat site and look at their all products, all software, go to their audio tools section, scroll down here and look for something called Gain Suite, Blue Cat's Gain Suite. Click on this baby. Now, what's wonderful about this plugin, it's free. It doesn't cost any money, so it's not going to stress your budget. And it comes in all these flavors and formats. I downloaded and tested the VST3 version for Windows 64. And I highly recommend you get this. I'm not going to derail this video by going into video how and why we use this, but it's going to solve a really useful problem with Clip to Zero. And I'm just going to show you, I have a project here with several instances, well, 100 to be exact. I have 100 tracks, each of them with this ganging plugin, this VCA style plugin. There's 100 tracks here, and there's a copy of Blue Cat on every one of them. So let me just go open up some of these on random tracks. Here's on track 1, here's track 57. Scroll down some more. Let's grab track 80, just as some examples. Okay, so what this is it's just a gain plugin, a trim, plugin. But what's cool about it is super lightweight. As you see, I have a project with 100 tracks on it and 100 of these plugins, and it's like almost no resource usage at all. And you can group them. So all of these plugins belong to the same A group. And it's set up in the way you see here. And so basically, if I change one of these gain knobs, it changes all the other gain knobs everywhere else in the project that are on the same group by the same exact amount. And of course, you can also hold your shift key and get finer amounts of adjustment or do big amounts of adjustment. So again, I don't want to bog down this video explaining why you want this. Just trust me, you want it. Go grab it, go get it, and then you'll be ready for the stuff I'm going to show you in just another episode or two. All right, so getting back to the subject of this video, the main subject, I want to do a bit of a correction here. So in this video, when I talked about one of the nice to have tools, something called newfangled saturate, I was explaining how saturate has this special, it's a spectral clipper. And so it, instead of making a perfectly razor flat cut across the top of your peaks like this, it preserves mid and high frequency detail and injects them across the tops of the clips. So it isn't a completely flat clip, it's more of a clip with detail on it. And that not only can sound better in some cases, but I made an explanation that was a little fuzzy and a little ambiguous and a little wrong. Okay, so I'm doing a bit of a correction here. Some users had some comments on this video, and I really, really thank them for these comments. And if you ever feel like I'm technically wrong about something I tell you, I welcome your comments. I am willing to grow and learn and consider or help you understand why your understanding might be wrong. But in this case, I think these were good comments. And so they made me go reevaluate what I thought I understood about this subject. So if you want, you can pause the video and look more closely at these. The bottom line is, I said in episode 3 that one of the things Newfangled Saturate was good for was making sure you didn't run into this problem, which is, this is one of the best summaries I've found out there of the problem. When you clip the amplifier in a speaker, okay, if you're clipping the amplifier and, this is a signal, this is electrical energy that's pushing the cone up, this is pushing the cone down. There's a lot of mechanical bounce and movement that happens because of the way speakers are constructed. But, the bottom line is there's energy that pushes the speaker out and pulls the speaker back. And as long as this signal is constantly moving, speaker systems are designed to cool themselves off, right? But if you push a speaker all the way to its max electrical voltage in the amplifier and hold it there at this max voltage for a long period of time, like you see in this razor flat clip across the top. Now remember, this is it's a representation of the amplifier, not the audio signal. If the audio signal, if you crank it so hard that it's actually clipping the amplifier, because you're pushing it way too hard into the amplifier, and it's holding at its highest power output for long periods of time, this heats up the voice coil in the signal, in the speaker, right? So it's heating the voice coil instead of actually producing sound. And so during the time span that the signal is flattened like this because of amplifier clipping, not audio clipping, when the signal is flattened like that, the loudspeaker is basically converting all the power into heat in the voice coil, the copper wires that are used to help the speakers move in and out. And you can melt voice coils, or you can at very least deform them or wear them out earlier, right? Heat is the enemy of electronics. So this is a basic principle about speakers. And this principle was kind of reinforced in a recent video by Dan Worrell, who has a lot of experience as a live sound reinforcement engineer. And he did I did entire videos in response to this video because some of his points were bad. But one point I didn't disagree with was this statement here, okay, towards about the 3-minute mark of the video. If you want to go watch this video yourself, it starts around the 3-minute mark. So he's making a point that if you play stupidly clipped masters in a big PA system, right, and they have those flat tops, he makes the point that those waveforms will rip through the speaker drivers like butter, regardless of how conservatively the front of house engineer is trying to set the limiters and keep the power from being too much, okay? So, this is a relatively well-known, relatively well-respected live performance engineer and a good engineer in general who makes lots of good technical videos about engineering. So, these things were reinforced in my mind. And that's why I made the point I did about, in certain cases on certain buses in your project, you want to be trying to minimize the amount of flat-topped clips you have. Now, that was not enough of an explanation, and that's part of what caused these comments. So let me dispel a little bit of misunderstanding and help clarify this a little bit. It is, in fact, a problem if on your master track right here, if you, like, I have seen producers out there who just proudly show that they are redlining their master and they're going way over 0 on their master and they're clipping the crap out of their master. And they go, look, it sounds great, it's fine, everything's fine. And I think Dan Worrell is right to rail against producers who do that. I do. I think that's a bad practice. It's part of the reason I use clip to 0. I want to do my clipping in a very controlled way where I know exactly what's happening on every track and every bus in my project. And I want to know by the time I get to the master that I'm not stupidly clipping what's coming out on my printed master. Okay? Because I know that this speaker driver thing is a problem. Okay? So a big part of my clip to 0 that I've never gone into in the past is if you do this intelligently by doing a lot of little clips all throughout your project, what effectively happens, and I've never explicitly said this, but what effectively happens is all these signals, as they sum together, all those flat tops kind of disappear. Okay? They're being overwritten by each other in various ways. And by the time you get up to a real, true master, the completely summed result of all of your tracks and buses on their way up to the master, it doesn't matter how hard you've clipped something on any specific track. Okay? You could be flat topping all kinds of stuff all throughout your various sounds in your mix, but when they sum together, it changes the waveform. And by the time you get to the master, if you've done it right, you're not going over 0, and there's almost no clips left. Period. Done. So there's nothing to worry about in terms of the speaker drivers. Now, that's a little bit of an oversimplification, and going into detail explaining it would have really derailed some of my already much too long earlier videos about clip to 0. So I'm addressing this point squarely here, right now. There's so many things going on. Part of it is that when we look at articles like this, they're talking about theory. They're talking about worst case scenario. Now, in practice, things are different than the theory, okay? So let's look at this picture one more time. This is showing you a power amplifier clipping, the amplifier that drives the voice coil on the speaker. If you overload the amplifier to the point where it's clipping, and then it's causing too much heat to build up in the voice coil, that's going to wear out the voice coil, blow your speakers over time, right? It's going to wear them out faster. Lifespan is reduced. That's a given. That's just how this stuff works. But that's theory. In practice, if you were feeding this speaker driver and this amplifier at a clipped signal that looked like this, but you were feeding it at half of its rated power output, then there's suddenly half the amount of heat being generated. It's no different really than if you had a regular normal sine waveform with no clipping, right? In terms of the amount of power that it keeps pushing into the amplifier. It's not an issue unless you're running these speaker systems at their right up at the threshold of their maximum power output and power handling characteristics, okay? So the number one thing to remember is this is true only when you are cranking everything to the limits of the system. If you're playing less than the limits of the system, it doesn't matter because, hey, this is how distortion is done. All the all the plugins you use to create saturation and distortion of various kinds, they do it by wave shaping the original signal in this way. They're flat topping the signal and maybe putting little rounded corners on it, and they're totally changing and clipping your signal to get those distortion harmonics. Okay, that's how it's done. That's how the sound is made. But it's not an issue unless you're also forcing the speaker system, the PA system, the subarrays, unless you're forcing them to reproduce that signal at the limit of their system capacity. Okay? Anything less than the limit, no problem. Or certainly less of a problem, because it's not about the shape of the waveform. It's not about the distortion itself. It's about whether or not the distorted signal is putting so much energy into the voice coil of the driver that it's starting to overheat beyond the capacity of the speakers designed to cool the voice coil of the driver. You know, there's movement, there's airflow, there's heat sinking. There's all these elements, and they're kind of designed to take a certain amount of heat for a certain amount of time. And then, you know, more normal movement at lower volumes will let the heat dissipate over time. And so it's just a game of not letting them get too hot. Okay, so that's one part of the theory. Another part of the theory is some points I wasn't aware of, and this is the kind of the new information I want to bring out here. These are some people that are pointing out it gets a little technical. It has to do with how waveforms are split through crossovers into different types of drivers in a system. But the bottom line is the one driver you really worry about are the sub-drivers, because they're handling the biggest, fattest part of the waveform. They're handling stuff that's happening around usually in the below 100 hertz range, below 90 hertz range, below 110 hertz range, below 80 hertz range. It all depends on the system and the capacity of the subarrays and where the crossovers are set. But the bottom line is a signal that looks like this. Wait, where is it? A signal that looks like this, that has this high energy detail kind of, you know, put in on top of the clip. Well, when this is passed through a crossover, the part that's getting fed to the sub looks a little more like this. It's going to be more sine wavy, and it could theoretically have that same clipping shape. But this is where I was wrong. I'm wrong about that. And these comments kind of highlight that. I think this one here, this sentence in the bottom thing, even a straight square wave looks like a rounded out sine to subarrays, because they only see the low frequency harmonics through a low pass filter. And that low pass filter is part of the crossover circuit, okay? And that was a point somebody was making up here in this comment. There's going to be a crossover. The woofer's only going to see a low passed version of the signal. No driver will ever see a flat top. And even then, the driver doesn't follow the signal exactly, because there's inertia from the physical weight of the drivers. There's resonances inside the speaker enclosure. There's all kinds of stuff. And so these people were saying, look, even this theoretical bit about if you clip the amplifier, you're putting too much heat into the system for too long. And so you could overheat your voice coils theoretically. These people were making the point that even that's not really much of an issue, because by the time you go through crossovers, there's all these low and high pass filters involved, and they're rounding out those flat top sections. They're putting curves on the end of them. And so it's looking more siney and less hard clipped or less square wavy. All right, so this may be flying over a lot of your heads. I barely understand this. I'll admit that, right? But I have a fuzzy enough understanding that, yes, I see what they're trying to say here. I also see what Dan Worrell's trying to say. A lot of environments don't have a front of house engineer sitting there all the time watching everything carefully. If you go into small and medium-sized clubs, there is no front of house person sitting there at a desk. There's kind of the house system that's set up a certain way, and DJs come in and Each DJ swaps in their USBs and gets up on the decks and does their thing. And, there's not a lot of control on the system. Only at really big festivals are you going to have front of house engineers with a lot of keen knowledge and know-how sitting up there watching everything really carefully and controlling everything really carefully. And they're basically remixing what's coming out of the mixer in the DJ booth. They're remixing everything. They're controlling signals carefully. They're pulling things down. They're making the entire spectral balance of what's coming out of your USBs totally different. Okay? Because they're taking care of the system and they're taking care of the acoustics of the environment. They're not only taking care of their expensive equipment, they're taking care of what the listeners hear in those big complex environments. So at the end of the day, I probably made too big a deal about this and why I sometimes choose to use newfangled saturate. I probably made a little too big a deal out of it. Didn't state the case clearly enough, and I'm just trying to set that straight right now. Now, there is still a grain of truth to this, and I will be talking about this in future episodes. It is true, you do not want your printed master to have a lot of flat-topped sections in it. Maybe super short blips here and there on highly, highly transient material, right? That happen occasionally throughout the entire course of your song. That's okay. But even then, there are some things we're going to talk about doing in later episodes where on higher level buses, like on my pre-master bus, on my 2 top-level drums and tonal buses, right? By the time we get to this set of buses, if there's any hard flat top sections in these buses, especially by the time they get onto the pre-master, they sum together into the pre-master signal. If I'm still seeing really big flat sections of clips in certain places where I know to look for them, and I'll teach you how to do that, I will use something like newfangled saturate to help with that a little bit. And I may even suggest going back and rethinking how hard you're clipping certain sounds and, making sure that it's not a problem by the time you get to the master, because you don't want big, long, flat clips on your master. You don't. In real world results, though, in your typical projects, it's a non-issue. You're never going to see it on the master anyway. You might take a certain really aggressive mid-bass sound in your drops bus, right? You might have nasty, nasty, aggressive, totally square wavy sounds that are right up at 3 RMS and 2 RMS with they're just sheared like crazy. And it doesn't matter, because by the time those aggressive sounds are mixed in with your drums and your drum tops and your sub bass and a whole bunch of other things going on, the waveform's going to look totally different and it's not going to look clipped anymore. Okay? So I will be demonstrating that later, and I'll talk about last minute things you might want to think about to make sure you aren't having big, long clipped sections on your master. This is a definite benefit of working in a clip to zero fashion rather than doing what Virtual Riot tells you and just cranking your master way into the red and saying, it's fine, look, it sounds great. Yeah, it may sound great. It's probably not so great for the PA system. I do think Dan Morrill is right about that. But we can avoid that by clipping a little bit more intelligently, clipping a little bit more intentionally with purpose and understanding what our signals look like. And again, that's one of the reasons in episode 3, I talked about one of the plugins you need being a good oscilloscope, because we want to see these waveforms and see what they look like and see where clipping is happening. We're going to be looking for clipping as part of my method. Okay, so we'll get into that all later. Thank you so much for hanging with me on this one, and I'll see you in the next episode. Bye-bye.